Happy Sabbath, everyone. So the head of the audiovisual said told me last night that told was joking last night that I should give lecture about the sound system. This is one of the most uh, complicated things here in the church at this moment. I think it's the most complicated thing I've ever seen. But this thing has been around, I think, from since 2004, and they have already sold like almost more than 200,000 units of this one before somebody uh, donated this to the church here, and we were able to use it. And but I have personally an X as the smaller brother and smaller sibling of this one. We have the XR18, and we also have the XR12. And my friend also, the son of the pastor, bought his XR18, and Sir General also has his own XR18. So there are quite plenty of us who have a digital mixer from Behringer, and this is one of the most popular, the Behringer X32 mixer. So I just want to, in short summary, the seminar I can give and the workshop I can give about this one, it depends on how much what you know and what you don't know. So because so that you cannot, we don't need to teach you things that you already know, and you already uh, if you teach you things that are too many new things, then it's bewildering also. So I just want to explain how this thing and a complicated setup here in the church and why it's a challenge, and for the sake of the understanding of the people in the audience and the people who are performing and the people who are speaking, so that we can help each other understand what the messages that are we supposed to hear and listen to. So basically, there's a microphone. The microphone has a small diaphragm. The small diaphragm moves, and that movement creates electricity either with electromagnetics or with chemistry, and that electricity creates microvolts, and that microvolts is amplified and amplified and amplified several levels until it is strong enough to move a bigger electromagnet, and the movement is also the same as the movement that comes into the microphone, and that's what's called a speaker. And that's what's inside the speaker. It's a magnet and a coil that moves according to how much amplified movement from the microphone. Yeah, and the mixer is when you have plenty of mics. You want to mix them all because you only have one kind of speaker going out, but you have plenty of mics going in. And some mics you want to be stronger, some mics you want to be weaker, some mics you want to be off, some mics you want to be on at specific times of the program. So this is what a mixer is for. Now we have the analog mixer, that's of course analog and digital, but the digital mixer has more functionality, more complicatedness, and cleaner sound because every wire, every patch cable, every connector contributes noise to the sound bus or the chain. In digital mixer, there's so much functions. It is cheaper if you count all of the functions. So, what are the functions in the mixer? First, let's go to the path of the sound. When the microphone wire goes into the mixer with the XLR connection, it uses a balanced connection. It has 3 wires. When it's working 3 wires, it shields it from noise. Usually the microphone wire also has a shield which helps prevent crosstalk from different parallel wires, and it is also twisted, which cancels the antenna effect. Furthermore, it uses balanced signal. That is not the same as the stereo signal, although it's also called one signal only, but it is balanced. That's not the same as the left and right hand stereo because the microphone is only one usually. However, there is a signal, and there is the inverse of the signal in the other wire. So there's a common, the return signal. There is the signal XLR. X is the ground, L is the live, R is the return or the inverse signal, more accurately. So the signal is like this, and the inverse signal is like this. Both of them travel to the wire, and both of them receive interference from neighboring wires and signals. When they reach the other side, the inverse signal is inverted again, therefore canceling all the noise. The noise cancels the noise, and the interference cancels itself. That's why it's amazing, this XLR invention. That's why the microphones have two wires, and if one wire doesn't work, they have noise and hum, etc., etc. Of course, ground loop is another different problem, while you have hum if you are connected to different outlet, etc. Yeah. So the solution for that one is isolation, transformer, or a DI box. Okay, in front, so that when the microphone is connected to the mixer, we have a preamplifier. The preamplifier has a gain knob. The gain knob is so that you can increase your millivolts into line level voltage. Line level voltage is what the components normally use, so that every wire has noise. And if you increase the volume, you also increase the noise. Yeah. So there are two now. So each channel, this has 30 channels. Each channel has a gain that tells the preamp how much gain it should have, and converts it to line level voltage, supposed to be. And the line level voltage has an EQ. You have high, mid-high, mid, and mid-low, and low and very low. Depends on the kind of EQ you have. So each channel has an EQ. And then you have the dynamics. In the dynamics, you have, this is the most amazing thing about audio, the dynamics, my friends. In the dynamics, you have what you call a gate. A gate turns off the signal if the signal is less than a specific threshold. An expander, it's called an expander slash gate. An expander, it doesn't turn off the signal at a specific threshold. The threshold, you can adjust the signal. So if there are weak signals you want to remove, you can adjust the signal to be the threshold to be over that. But when you speak, your voice is above that signal. So when you speak, the channel goes open and connected. When you don't speak, it is disconnected, therefore eliminating all the electric fan noise and the aircon noise and the small noise that are not supposed to be. But you have to speak louder than the electric fan for you to open the gate when you speak. That happens automatically and very fast, and it's one of the amazing things you can do in audio engineering. Problem is, it cuts too much, too fast. So we have what we call expander. It doesn't cut the signal, it just decreases the signal by a specific ratio. So gate and expander, same function, but the gate is a strict 100% expander. The expander only slashes the signal by half or by 1/4, depending on the ratio you put. Next, in the dynamics section, is the compressor. The compressor is one of the most amazing thing. The compressor prevents the signal from going higher than a specific threshold. Yeah, so if somebody is shouting and you set the threshold here, the signal will not go above that, but it will be compressed. Yeah. How much will it be compressed? Depends on the ratio. You have a ratio. You want it to be compressed half. Everything that goes above the threshold, will only half of it will come. Or if you want it to be 100% infinity, nothing will pass through above that. So everything will be almost clipped or limited. A 100% compressor is also called a limiter. Yeah, there's a hard limiter that makes the wave like this and destroys the speaker. And of course, there's a soft limiter that doesn't put corners on your side wave. Most you're using soft limiters, of course, so that your speakers will not be disentangled with the coils. So we have the compressor and the expander and the limiter and the gate, the most amazing thing, and it's automated, and each of these channels, 32 channels, and each of the 16 output channels, and each of the matrices have dynamics. Each of them have dynamics. So nice. You can control all of them and get lost what you're doing. So all of those channels have what we call, and this is not one mixer, this is 16 mixers. There are 16 sub mixes in this, aside from the left and right main mix. So it's such complicated thing. 16 times 32 You have so 300, so many things. 16 times 32, that's a lot of the mixing that you can do with this one. So there can be 16 channels. 16 there are 32 channels. You can mix a different mix for the live, a different mix for that speaker, that speaker, that speaker, if you want to be confused. So now all of the outputs also have dynamics. You can set this speaker to be until this level only. Even if you increase the volume, it will compress. Yeah, you can set this microphone to not open with an electric fan, but only open when the voice is heard. And so many nice automated things. But if you don't set it up properly, you can get confused also. If now there are two there are if you watch in Google and you listen to many audio professionals, there are two schools of thoughts that how to set up the mixer. The first idea is that you should make all of the faders unity 0, and then you should turn on the mics one by one and twist the gain and get unity gain, some signal there to a specific degree, and then you set all of them the same so that it's very easy to level all of the signals equally. The second school of thought is that you set the gain first to a specific level where it is yellow, and then you don't bother with the faders. You bother with the faders later when you want to send them somewhere. So that is a better idea in my opinion, and also in the opinion of the company who put a tutorial, the company who manufactured this one, Sweetwater Tutorial. That is also their suggested school of thought that we follow with this one. The reason is that if you have plenty of mixes, you have a mix for the house, you have a mix for monitor piano, we have a mix for stage monitor, you have a mix for live, and you have a mix for what else do you want to mix for? Only those things necessary. Hopefully you are not mixing every speaker differently, because it will just make you more crazy also. So you have live, you have main hall, you have monitor piano, monitor singers. The monitor piano and the monitor singers, you only use them when they're requested. You just mix the main hall, or you can mix also the live if somebody wants to concentrate on doing that one, trying to make the live mix better. But otherwise, we can just copy what is coming out of the main and feed it to the live, for simplicity's sake. Yeah. The problem is if we follow the idea number 1, where you set unity gain, unity fader, unity 0, and then you twist always the gain instead of the faders. If you have plenty of mixes and you already set the mix in the live and the mix in the monitor and the mix, and then you twist the fader very quickly and you increase the gain, you twist the gain, it will destroy all of the other mixes, because the gain of the channel affects all of the signals that go into all the other mixes. That is what's happening sometimes. That's why that is one of the factors that's happening sometimes. That's why it's very feedbacky and then there's no sound even. Another factor that can happen, which makes it difficult to control this, almost impossible to survive without errors in the performance, in the control of this X32, is when you have too many speakers. Like if you set up all the speakers as a different mix bus, then when you need to turn off the piano, you go to this mix bus that speaker, mix bus that speaker, mix bus that speaker. Okay, you can count CR left, CR right, main fill, CR left, CR right, main fill, fill right, front fill left, monitor left, monitor stage monitor left, stage monitor right, piano monitor, left wing, right wing, live. You have 10 things to mix, my friends. So what we did, we tried to simplify by just copying main, since most of the time only one person operates this mixer. If somebody wants to volunteer to operate live, then we can also do live mix for that one. But most of the time, we want to simplify so that it is manageable. Mixing only one mix, the main mix only, so that it's easy to manage. And the easier to understand, easier to manage, then less problems, less troubleshooting, and less mistakes. Yeah. So it's very complicated, and you have this big hall. There are 1,500 seating arrangement, and we have a stage. Now what we do, I just repeat this from the other video. What the technique I'm suggesting is that when somebody is performing or singing or speaking there, we first get as much gain before feedback as we can with the main hall. So all of those groups of speakers, we separated matrix. This thing has called matrix. So we send the main to make matrix. A matrix is like an output, and the matrix can be mapped to outputs, and the matrix can control like the whole mix. So for example, this is the right wing. I want the right wing to be separate, volume control these two speakers from the main hall, but I want also to copy the volume control of the main hall and the mix of the main hall. So we can use a matrix for that. So what we did with this setup now, hopefully it's more simple, but you should message us if you have a better idea, a simpler idea that is easier to manage. So we have only main LR, we have monitor mix. I made only one since they're same sound anyway. Piano mix, and we don't use these two unless they request. And the live mix. And the live mix, we also don't separate it usually unless there is a Sabbath School's microphone or but we have another solution for that now. So all of these groups of mixer, the left wing, the right wing, the front fields are the small speakers that are pointing to this dead spot, because all of the speakers up there are pointing almost 45 degrees going back. So these people in the front don't hear any speaker. So we have the front fields there, and there's a different volume control. So the idea is to prioritize the house mix first, and then if there is time or the song is not yet finished, to fill the house with sound, and then you see it is gain before feedback. How do you know how much gain? You just increase the gain slowly until feedback happens, and then the sweet spot is before the feedback happens. So it's about trial and error and practice. The more you practice with the choir, the more we practice with the performance, the more we practice with the instruments, the more we practice with the sermon, the more you know where it is with the whole also, and with the sound system and with the venue. So first, my suggestion is that we prioritize the area with most listeners. We get the gain before feedback, and then this part, there are also plenty of listeners here. We get the gain before feedback here, and then that part is very difficult to monitor because we cannot hear the sound there. We can only hear the feedback and adjust it one by one. If you adjust it all the same time, you don't know which part is contributing to feedback. So you're gonna reduce all of them at the same time, and you repeat again. If you look for the gain before feedback for the house, and then you nail that there, look for gain before feedback for here, you nail it there, and then that side, and then the front field. So you, in sequence, depending on how many people are there, the biggest is the main hall, a second is the front fields, and the third is the right wing, left wing, and or depending on how many people are here, that's how we prioritize putting sound, guessing where is the gain before feedback for each segment, which speaker, and then we can maximize how much gain each section we can give before it feeds back to the main microphone. And for the speakers, instrumentalists, singers, You can help this process by putting your microphone nearest to your mouth as possible, but not nearer than 1 centimeter, because 1 centimeter to less than 1 centimeter creates distortion already in most microphones. So please put your mic as near as possible to your mouth, because the nearer your mic is to your mouth, the more gain we can put with before feedback. Actually, we don't need to put gain because your voice is very strong, and we don't need to put gain too much, and your audio will be strong everywhere. The farther if your mic is 1 inch, if your mic is 1 meter away from you, then we have to put the 3 times, 30 times, 20 times the amount of gain as we have it here. And if it's 20 times, I think it cannot sound without the speaker sound being picked up by the mic and causing feedback. That's the theory. What's happening to the sound and how this sound system works with microphone and the sound system and the whole. How about the reverb, the echo? That's about the function of the whole. Yeah, it's very hard to understand because there are so many sound sources and so many reflections and so on. So if you want to hear clearly, you sit in front of the speaker so that the main signal can overpower the echoes and reflections from somewhere else. Faith cometh by hearing, and hearing by the word of God. So that is important. Habakkuk says we have to make it clear. Habakkuk 2:22, make the vision clear, so that he who hears, he who reads may run. Yeah? The most important thing is the message, all of the preliminaries, and of course, if the song has a message also, especially if it's understandable, it's better. It will help people memorize the message, the songs. Thank you, everyone. I hope we can understand how to take advantage of these amazing tools for God's work. Have a nice day.